So welcome, glad to have you all with us. Welcome to California Lutheran University School of Management Tech Talk. Our Tech Talk series runs about once a quarter, and our goal is to give you some exposure to interesting thinkers in the technology space. We've had folks from healthcare, we've had folks from the information security industry, risk management, insurance, and a variety of other places. We've got a speaker coming up in biotechnology. So we've got all sorts of interesting folks to hear from, and we're glad you're here with us. I wanted to introduce, before we get started, my dean, Dr. Gerhard Apfeltauer, to greet you for the School of Management.
Well, thank you very much, Paul. I'll keep it short. Our audience certainly didn't come this afternoon to hear me speak, but they are here for a very exciting speaker in our Tech Talk series. I just wanted to welcome everybody. I see we have students here, we have faculty members here, we have alums and community members, and that's exactly why we have the Tech Talk series. We understand the series as a bridge between the excellent academic programs that we're offering at the school, including the MS in Information Technology program that offers professional tracks in data analytics, among others, and industry. And those links really go both ways, right? We are proud to offer a very hands-on, high-level education, applied education to our students, but we're also happy to work with industry to understand the needs that are out there, and also to supply, especially important these days, the workforce for the future. So thank you everybody for being here this afternoon on a Monday evening at the beginning of a very busy because short week. We appreciate that, and I appreciate especially that Dr. Jeremy Greene is with us today. And with that, I'll turn it back to you, Paul.
You'd think I know how to do the mute button by now, but oh well. So as you see on your screen, we do have programs in a bunch of different fields related to the general science of management, and we're open to have your interest in any of those things. If you are looking for an advanced degree, or if you know someone who is, please feel free to send them our way. And without any further ado, I'd like to introduce Dr. Jeremy Greene, who's here to talk with us about his work in data science in a variety of spaces, and I'll hand the ball over to him. We will have time for a few questions at the end, so if you have questions along the way, feel free to send those to us via chat, and we'll address those as best we can when we get to the end of our time together. Jeremy?
All right, thank you. Can you hear me? Sound check? All right, can you see the screen? All right, thumbs up. Thanks so much for having me. Really excited to be here. A little bit about me. I grew up in Agora Hills. My family still lives there. I have family members that went to CLU. So I'm very excited to be here and share some knowledge with you about myself and careers in data science, and actually dive into some pretty practical applications as far as how I've seen data science, and my teams in data science have interacted with marketing, digital marketing, growth marketing, etc. So a little bit about me. I've had a very windy journey. I loved math. I loved pure math. I loved the theory. I loved everything about it. So I went to grad school in pure math to get a PhD, and I took zero, like no probability, no statistics. I took none of that in college or grad school. I got very involved with just my research and in pure math. I wanted to go into academia and be a professor. That didn't quite pan out as I had planned and as I had hoped. So I did get recruited by the government, National Security Agency. I actually flew out there and had a 3-day full session with mathematicians there and polygraph and that whole thing. And I got a job offer at NSA. That would have required me to move across the country. So I turned that down and kept applying locally. And I had no business background, by the way. And this thing called data science, this was 10, 11 years ago, it was just starting to get interesting. I just started reading about it. It seemed great. It seemed like a way to apply all the theory and math that I had worked on to very interesting problems. So here's just a brief CV resume of what happened to me after graduate school. So I went to UC San Diego for all my schooling, all studying pure math, like I said. Got my PhD in 2011. After that, I went to FICO, also known as Fair Isaac. They're best known for the credit score, but I primarily focused on building fraud detection models for insurance companies, medical insurance, health insurance, pharmacy insurance, dental insurance. So I spent 5 years there. I led research and development for my team, filed a few patents on outlier detection. And then I got this incredible opportunity to be the first data scientist hired at Acorns, the micro-investing fintech mobile app. And I joined there in 2016 in the summer. There were about 100 people. Again, I was the first in data science there, and I spent the next 4.5 years building out the whole data organization pretty much from the ground up. By the time I left there early this year, we had 14 or so people in the data organization. I was overseeing business analytics and data science as well. Launched every product that Acorns offers, helped scale that business, and they're actually going public this year. So that was a very exciting career win for myself. I spent a short stint at Farmers Insurance, actually leading a team in the distribution line, helping build out data science at a big company. So trying to move that company into 21st century in technology and data science best practices. And now I'm a vice president and head of data science at Retina AI. We're a Series A funded startup. We have about 25 people, and we're the leading industry leaders in customer lifetime value management. So we can predict customer lifetime value as early as day one with the customer's interaction with the brand. So that's a brief stint of my resume. And so, the first part of the talk will be more soft skills and what does a data organization look like? What does a data organization look like in a big company, a small company, an individual contributor, management in the data side? And then I want to get into some real applications. There's going to be a little bit of technical pieces in there at the end, but hopefully it's not too much. So data organization consists of lots of different departments. And depending on the organization, this is split in multiple ways. There's business analytics, there's data science, which you can think of as machine learning or AI. These terms are used a lot. There's data engineering, which is moving data around from one place to another, owning data assets, really feeding data science the inputs that they need, or analytics, the inputs that they need to build dashboards, to build models, keep all the plumbing going. And being in the data science team and growing a data science and analytics organization, it's really critical for success to be a partner with the entire organization. Data science, the data leaders have to have a seat at the table in all planning and road mapping sessions in the business across product, marketing, growth, retention, you name it. Data science and analytics should have a seat at that table. And interestingly enough, I would also say being in the room for product design and engineering design at the very start of any sort of product ideation is critical. Oftentimes you're running a mobile app or a website. You want to be able to track who's coming in, who's looking at screens, who's clicking on buttons, who's looking at a screen but not clicking on a button, what keystrokes are being entered in. And a lot of times those things aren't thought of unless a data person's in the room. So very important to make sure that data science and analytics are not looked at as a back office function, not an afterthought. And in order for data to be a driver for impact, they must have a seat at the table at the very beginning. My experience in medium to large size companies, data organization, and being an individual contributor and a manager, typically there's and I'm not talking about the Microsofts, the Googles, the Facebooks with hundreds or thousands of data scientists. This is really drawing on my experience where I was at Farmers and FICO. We had 50 to 70 data scientists. They were organized into smaller teams of like 5 to 7 or 10 groups of data scientists. Typically, they supported a single product, so very siloed. That group of people had a very prescriptive job. They ran X, Y, and Z, and they did it over and over again for multiple clients. Very process driven. Maybe you learn one programming language, maybe a second programming language, and you get pretty deep in that, as big companies tend to have certain processes and a certain way of working that you get really good at one or two things. It's typically more 9 to 5. You wear one, maybe two hats, very structured in company culture and operations. And the customers can be anywhere from B2B, like you're selling a service to another company, or direct to consumer, B2C. And some clients in the B2B space, they pay millions of dollars for whatever you're building. So that's been my experience in medium to large size companies. And being at a small company or a startup, very different, very, very different. So at times you could be the only data scientist, or maybe there's 1 or 2 or 3 of you. You really have to go in and evangelize data science. You have to be a champion. You have to go convince other people why data science and analytics are important, why to believe in data. You have to be able to show value in what you're doing. So you get buy-in from other stakeholders. You have to wear many hats. So throughout my time at Acorns, I was not just a data scientist, I was an analyst, I was a data engineer, I was a product manager, I was a project manager, I was a salesperson, I helped with business development. I mean, I wore every hat you could think of. The work is a total variety. It's not just building a model or building a dashboard. It's a very much find a way mentality. You are most likely on a runway of cash, burning through money, and you don't have time to just build a solution that can scale for the next 20 years. You need to build a solution that can work for the next 1 year or 2 years. You have to be able to be agile. You have to be able to pivot as necessary. It's very likely that you start a project in a data project at a small company or a startup, and then you don't even get to finish it, and you have to put it on the shelf and pick up something else. There's a lot of growth opportunities for individuals and managers and the employees of the startup. You get to be, I tend to say that 1 year at a 7, it's like dog years. A year at a startup is like dog years, how you get experience and how you age. So there's a lot of ways to grow your career. Company structure and operations are not as set at a small company. You have this executive level. Everybody is accessible. You're in meetings with the executive level. You're presenting to executives. You're presenting to anybody and everybody at the company. You have a huge impact. You operate cross-functionally. A lot of collaboration. You tend to learn multiple programming languages. It's another find a way mentality, and use the language that best fits the program that you're trying to write. Time is money. It's not as 9 to 5. When I was at Acorns, we were it's a bank, right? It's a money app. It's a financial investment tool. You round up spare change and invest it into the market, and then there's a debit card. So you're essentially operating a bank as well. And it's an app that's open 24/7. And so if something happens at 3 a.m, there are people that wake up at 3 a.m. and are on call to fix problems. So it's very different at a small company or a startup. My experience as an individual contributor is your skills are very much more tactical, building models, coding, writing SQL, Python, R, Spark, working in AWS, doing data analysis, statistical analysis, developing the models, building the dashboards, designing APIs, integrating with the engineering team. You're in the room, you're code sharing, pair coding, QAing with engineers, project planning, communicating across departments. Sometimes as you grow in the individual contributor ladder, you mentor colleagues, lead technical projects around the organization. but it's a lot of, you're not really responsible for somebody's career path in data science, which is a challenging job these days. So management and leadership in data, what does that look like? A lot of, so my job is, I'm in a startup now, but I actually still code as well. But I'm also responsible for the strategic direction of the team and the organization. Responsible for the people, their career growth, leading the team, mentoring junior team members, personnel, HR. I have to be able to prioritize, resource plan, building a roadmap, project planning. It's less tactical and more on the strategy side. So what are some new projects that we can build that will drive company value? What is the value of the project that we're building? Less on, okay, should I use this function or that function in my Python code? A lot less of that. And it's a lot of evangelizing. So you have to be the champion, the supporter. You have to go to all the other departments and say, hey, this is what we can do. This is what we can do with data. A lot of times, other people at the organization may not understand what's possible with the data. So it's also your job as a data leader to brainstorm and be that champion, that evangelizer of the art of the possible. What is possible? And at the center of everything, I've spent 10, 11 years now being an individual contributor and now building and growing teams, very high-powered functional teams, and I've hired a lot. I've had to do talent reviews, and so I've kind of put together this circular ball of like what makes a good analyst, what makes a good data scientist from my perspective. Certainly the math and the computer science, that is something that you use every day. You have to know how to program and know some of the math and the statistics, but you can learn a lot of that as well. So you have to be able to be a learner. You have to approach this career and field as being a lifelong learner. You can't ever be stagnant. This field moves so fast. There's always new technologies coming out. There's always, the academics are publishing papers on new methodologies. So you have to try to stay current as much as possible. Time management. This is something that if you're a data scientist or you've tried building a model for a predictive model for something, you know that you could actually spend an indefinite amount of time playing with the data, feature engineering, cutting it, slicing it, looking at it this way, that way, trying this model, trying that model. But you can't do that in industry. You just don't have that kind of time. And oftentimes you have a deadline or a date, and you have to be able to manage your time and know when enough is enough or understand the 80-20 rule. Problem solving. This is another big one. I'm a firm believer in that there's always more than one solution to solve a problem. There's never just one solution. And oftentimes we deal with very vague requirements. I'm actually working on a project right now with the rest of my data science team. It's a pretty vague project that as we've talked about internally at the company, and we have to try and fill in the vagueness. And so that requires a lot of problem solving. We do a lot of brainstorming sessions, but sometimes we have to think outside the box. Being able to be agile. Things that you try as a data science practitioner, they're not going to work. You're going to try something, it's not going to work. You're going to try slicing the data one way, cutting it one way, it's not going to work. You're going to try building a model, it may not work. So you have to be able to pivot and be agile. You may be expecting a certain level of data cleanliness out of your data warehouse or out of data that you're about to build a model off of, and it won't be very clean. And so you have to be able to be agile and pivot and understand what you need to do. Proactive curiosity has definitely set the great apart from the good. Are you a data scientist that you do what you do what you're told, or you do what you're asked, and you come back and say, I'm done, that's it? Or do you go into the data, when you get in there, you start looking around, you start finding things, you get curious. Okay, I was asked to answer this question, but in doing so, this other thing came up. What do I do with that? This is a very interesting finding. So having that proactive curiosity really can set apart the great from the good in this field. Because you could definitely find something that is an interesting nugget, which hopefully I'll show you an example of later. And then communication. You have to be able to communicate less as you're more junior. When you're a more junior person in this space, communication is less important, but still very good. It's still very important, but it's less important. As you work your way up and start presenting to management and executives, you have to be able to communicate what it is that you're doing. Not every CEO or CFO or COO understands what an AUC is, or these weird metrics that we talk about in data science. Here's some of the data sets and applications that I've been exposed to in my 10 years. Again, insurance, fraud detection, in a variety of verticals, energy, electric smart meters. I've dealt with kilowatt usage coming out of your electric meter in your house. I've dealt with GPS pings from a cell phone to determine whether you're driving a car or in a bus. Did a little bit of cybersecurity stuff, but not much. A ton on bank and credit card transactions from my time at Acorns. We built fraud detection models that save millions of dollars a year. Spend and income analysis from people's paychecks. We could build a paycheck model to determine when someone's getting paid, who their employer is, and understand if they are spending more than they're earning. We had some brand recommendation engines running with the marketing team and inside the app. And then mobile apps, trying to understand in-app behavior. Who's logging in? What screens are they going to? What's the funnel on the growth marketing when you download the app and open it for the first time? What percentage of the people sign up, enter their email address? What percentage of the people go to the next screen, the next screen, the next screen? Understanding customer retention and lifetime value. A lot of work on marketing, customer acquisition, and A/B testing. So what I wanted to talk about in a little bit more depth is how a data science and analytics team interacts with a marketing team. And there's a lot of ways here. So specific targeting, email marketing, targeted emails. Do you just blast an email to your whole customer base, or do you surgically target who you want to send an email to? Same with push notifications on your phone. They're pretty invasive. They ding, you think it's one thing, and it's a push notification from Postmates or Uber Eats or something. In-app notifications. When you open up an app, open up one of your apps, how often is there an ad that overlays that you have to X out of before you get into the main part of the app? How often do you market a new product or a new feature, or referral bonuses or referral codes? Growth and retention, so customer acquisition. So I'm going to talk about that a little bit later as well. How do you spend your marketing dollars on Facebook or Google or TikTok or advertising? How do you analyze that? And customer segmentation. So how do you are there different groups of customers that are behaving in a certain way or a certain demographic that you want to treat them differently inside your product or inside your marketing journeys? And then of course, A/B testing and experimentation. This is huge. You always have to be, running experiments to always get incrementally better on every type of marketing that you're running. So I have 3 case studies. This one is the most, I would say, the most involved. It may get slightly technical towards the end, but hopefully you get the gist, the big gist of it. So, and these case studies that I talked to you about are based on very real, true problems that I've had to solve with my teams. Things are just slightly tweaked, so it's not pointing to a specific implementation. So the big question is, will you shop at Target? Target being the retail store within the next week. And why do we want to know this? Because you're a company, you're running ads. Maybe you want to show a relevant target ad to customers at the right time. Traditionally, these emails or ads, they just get sent or shown to everybody. Think about you get probably tons of spam, junk email every morning. You wake up, your inbox is flooded with just tons of stuff. I go in and unsubscribe because it's not useful for me. But in an app, when you see an ad, that real estate for a company to show an ad on your phone in an app, it's very expensive because your phone is small and it's often probably going to take up a large space of the phone, and you need it to be relevant. And here's an example. If you send this to everybody, you show an ad to your whole population. Yes, you may maximize your volume of ad interaction because you're sending this to everybody, but maybe only 3% of these people are actually going to interact with your ad. That's a pretty low number, 3%. And in doing so, you have an increased risk of people unsubscribing or getting annoyed with seeing an irrelevant ad. So let's say you send an email ad or show an ad to 1 million customers in your app. Maybe you only get 30,000 interacting with this, but you've maybe upset 970,000 people that this is irrelevant for. And so how can data help? Can data help? So suppose you have information about somebody's transactions, where they're shopping. You see these, if you log into your bank and credit card statement, you might see some really messy information like that. Sometimes I can't even understand my own statements on what was this, where did I shop? So there's a lot of data cleaning that has to go in. You want to understand somebody's shopping patterns at Target. Did they shop at Target? Did they not shop at Target? When did they last shop? How much did they spend? And maybe this can start informing you on who to show this ad to or who to send an email to. And so setting up a problem may look like this from a data perspective. You collect a bunch of historical transactional data, a bunch of history. You go back, many months, and you have, let's say 2 to 3 months of transactional data. You can take these months, this historical time period, and run what's called like a back test, or you train a model on 60 days of data and test it on 7 days of data that you already know the outcome. You already know if these people shopped at Target within a 7-day window. And so you can build a model that looks at the prior 2 months or 60 days. Let's just make it simple: number of purchases, money spent, and maybe it's the recency. You can look and see the last time they shopped, and then make a prediction. Do I think this person is going to shop in the next week? And maybe this can help inform who you show an ad to. And so as a data science practitioner, you have all these different choices. You have this huge list of models to pick from. And I always ask somebody, what would you pick and why? And most often it's, I'll pick a neural network. This is most often answered in an interview setting. I'll pick this. And the challenge, there's one major challenge with this, major challenge with this. For a data science team, this could be great, but you're interacting now with a marketing team that needs to understand customer behavior. And the problem with this is that you may not understand what's actually driving the predictions. It's a black box. So a logistic regression is a very simple linear model. It's explainable. You can actually get coefficients and understand what they mean. There's tangible interpretation. It may not be as accurate, but you can understand it. More frequently you shop, higher likelihood someone's going to purchase in the next week. The more money you've spent in the past, higher likelihood you're going to purchase in the next week. This is something that's very tangible. And I know I've simplified this example, but imagine putting in here different things that are like, did they see a coupon in the past? Did they see an ad in the past? Did they interact with an ad in the past? What's the product that they bought? If you use a neural net, you may not capture relevant information. You may get really good predictive accuracy, but you may not actually understand what's driving someone to make a purchase. So when you're working with a marketing team and you're the data scientist, you build a model like a logistic regression model. The output of this is a real number between 0 and 1. And somebody has to make a decision. Tell me the cutoff threshold. Tell me, okay, I've got these scores between 0 and 1. Who am I going to show the ad to? It's great that you have these scores, but what do I do with them? And so someone has to make that call. Okay, am I going to send this ad to everyone that has a score at least 0.8 that's going to shop in the next week, or 0.5 or 0.2? How do I make that determination? Well, this needs to be a business conversation. What's worse? Do you not want to show someone an ad when you should have, or do you want to risk showing someone an irrelevant ad? And this is a very good business conversation that a data scientist can have with the stakeholder. This is typically like a precision recall trade-off when you're a data scientist building a model. But I've had many of these conversations with stakeholders, and how do we want the audience to receive a marketing message. And one thing you can do, this is the most technical slide, one thing you can do is actually run a test. You can run an A/B test, and you can take 1 million customers. I know this is a large test, but bear with me. You could take 1 million customers, take half of them, send them all the ads. So let's take 500,000 people, send all of them the ad. We know from our first slide, we should expect roughly 3% conversion rate or interaction rate. So roughly 15,000 people are going to interact with this ad. And then the other half, the other 500,000, we run them through a model. They get some sort of score. And then let's just say we actually show the ad to the top 10% of scores. So the people that receive the top 10% of scores. So we'd only show the ad to 50,000 people, and we get 20% conversion rate on those 50,000. So we've selected a highly targeted group of people that we think are going to respond to this ad. Only 50,000 people. We get 20% conversion, which is much larger than the 3%. But if you do the math, that's really only 10,000 people out of the original 500,000. So we've been much more targeted, but we've lost a little bit of conversions total, 15K to 10K. So the question would be, like, is that okay? Is that acceptable? Should I roll this model out to everybody? And just every time I run this model, take the top 10%, show them the ad, and expect my 20% conversion rate. And you are going to get less conversions overall, but you're going to be highly targeted, highly selective on who you show these ads to. So out of the 1 million people, instead of getting your full 30,000 conversions, maybe you get 20,000, but you've only shown the ad to 100,000. You've actually saved, a potentially irrelevant and obnoxious or annoying user experience for 900,000 other people. And so the question is, what's that trade-off worth? And so that's a good discussion between a business stakeholder and a data team. The next two case studies are pretty quick. They're much shorter. Similar vein, but monthly advertisements. You're a company, you roll out a new product, and this is again another real example. You roll out a new product, okay? You're rolling it out, and you want people to adopt this product. You want people to sign up because maybe it's a subscription model. People sign up for this product, it costs more, right? So you want to upsell your existing customers to a new product. So your marketing team says, hey, we have this strategy. We're going to show this ad. We're going to show an ad for this new product to every customer once a month. So on the first of every month, we're going to blast out an ad for this new product. And we're going to do this every month until the people sign up. Okay, we're just going to blast them. So we're going to send everybody this on the first of the first month. Whoever doesn't sign up, we're going to send it on February 1st. Whoever doesn't sign up, send it on March 1st, April, May, etc. So what's wrong with this? Well, a lot is wrong with this. And how can we use data to improve this process? So can we actually stop showing somebody this ad, even if they haven't converted? At what point should we just stop showing them the ad for this product and free up that real estate for something else? Well, you might think that a really fancy model should be used. Do what we did on the last thing, and let's build a logistic regression, or let's roll this out to everybody in the first month and the second month, and see who responded and who didn't. But if you've done this for a few months, what you can see is you get really high conversion after the first month, not as much after the second time someone sees it, and then the third time someone sees it, and fourth, fifth, sixth, you get very little return on those ads. So, a very simple solution here is show it to somebody twice, and after that, don't show it to them anymore. Free up that real estate for something else. So this didn't require any fancy model. It was just a different way of looking at the data. This was a problem that we actually had to face at Acorns and rolling out a new product. The marketing team asked for a really fancy model, and they had been running this for like 6 months without us knowing. And all we did was plot this graph and said, okay, how many people converted after seeing it once, after seeing it twice, after seeing it 3 times? Like, just stop showing it after 2 times. And, that's it. If they don't convert after 2 times, show them something else. So really neat way to use very simple data to think about the problem, think about who's the customer, who are they asking, what are they asking about, and just problem solving quickly. Something else that could be very important is called uplift modeling. And the idea here is, do you poke the bear or not? Who do you bother with an ad? This is another way that a data team interacts with the marketing team is, you have people that are current customers and you want to retain them, or you want to offer them another offer, and there's going to be the customers that they don't need your ad. They're going to sign up for whatever you're offering, no matter what, without an intervention, without an email blast, without a push notification. Those people are going to sign up without that. Those are the sure things. So don't waste your time. Don't waste your time on them. Then there's going to be the lost causes. These are the people that your customers that they're not going to do it no matter what. Okay, these people, they're not going to sign up for whatever you're selling, no matter what you do. You could hit them over the head with it. They're not going to sign up. So don't bother with them. There's the sleeping dogs. These are like the anti-customers. These are your customers, but if you poke them with an ad, they're going to get pissed off and they're going to unsubscribe. They're going to close the app. They're going to close their account. They're going to stop using your product. And you got to be careful of these people. And then the persuadables. These are the ones that you should actually try to go after. Will the treatment, will what you're about to do actually change their behavior? So can you actually, get somebody to refer a friend? Can you actually get somebody to sign up for this product with an intervention, by seeing an email, by seeing an in-app notification, by seeing a push notification? This is hard to do. Solving the uplift model is not easy. It's a hard problem. You have to collect a lot of data, but it's a very fascinating data science problem that if any of you are running data teams, I think your data teams would love to look into something like this. Very, very fascinating. And then the last thing I'll close with is an example in customer acquisition and growth marketing. Companies spend lots of money advertising on Facebook or TikTok or Instagram. I don't know how many of you do social media, but you're seeing ads. And oftentimes, if there's a service that's free, you're the product. And so, that service is selling ads to you and the customers, the clients. And so one thing as a growth marketer on how do you operate with a data team? How do you operate with any data? Well, you want to understand your customer acquisition costs. If any of you watch Shark Tank, Kevin O'Leary, he's always asking about customer acquisition costs. It's super important. And it's very possible that you've run tests, you've spent different amounts of money on different channels. One day maybe you spend $5,000 on Facebook, the next day you spend $10,000 on Facebook, the next day you're spending $30,000. There's a chance that there's spending all over the place, and you keep track of how much you spent and how many customers you got. And then a standard metric to keep track of is your average customer acquisition cost. So the more money you spend, the more customers you get, and then your average customer acquisition cost goes up. And here's just a simple diagram of what a chart might look like. The more you spend, the more customers you get. And this is a very, very common way that growth marketers look at this data. Now, there's one piece of this that, yes, this is good, but there's one piece of this that is a missing puzzle piece on growth marketing and acquisition. And that's what's called the incremental customer acquisition cost. So as you can see here, all these increments, for every $1,000 I spend more, I get more customers, but that marginal gain starts decreasing, right? So my customer acquisition cost is going up, but it's slow. And so what happens is if you actually just look at how many more customers, how much does that next customer cost? The blended customer acquisition cost at $12,000 spend may be $15, but those next 20 customers you got cost $50 each. And so you have to be able to understand how much is that next customer costing me. And the story here is, imagine if you could know that across all of your marketing channels. If you're spending money advertising on Facebook, Google, TikTok, Instagram, Snapchat, all these social channels, if you knew on each channel how much the next person costs you, I bet you would shift your budgets around on how you're spending money across your channels. You might not want to pay, Facebook is costing you $100 for the next customer, and Snapchat's costing you $8 for the next customer. I bet you might want to switch some budget around between those two channels. Now, one thing that I'm not talking about here is lifetime value of a customer. And so, yes, you do want to take into account lifetime value. So, maybe this customer is costing you $50, but their lifetime value could be $500, so that's another wrinkle to this. But the moral of this is, don't just look at the average blended customer acquisition cost. Look at how much more that next customer is costing you on a specific channel. And again, this is something that's hard to figure out. It's hard to find. We started doing this at Acorns by running experiments, but it wasn't super easy to solve for. So that was the whirlwind of everything I wanted to talk about. I wanted to give you a good chunk of just the softer side of things on what it's like building a data organization, what it's like working in a big and small company, leading a team, and then kind of dive into how can a data team interact with a marketing team, and give you some use cases. All three of those case studies were real case studies, real problems, tweaked slightly, but real problems that were solved. One thing I don't know if I mentioned enough was, as a data leader, being able to tell the story of what kind of value you're adding to the organization is critically important. We spent 1.5 to 2 years building fraud models at Acorns for our debit card, and we kept track of the money that we were saving the company. So when I would present, say, hey, we've saved $5 million so far, and that was really good ROI. And the growth marketing stuff that we did, we saved $2 to $3 million in 6 months. We got more efficient by 7 figures. So yeah. So that's what I had to share. Happy to take any questions at this point. Feel free to contact me. All
right, thank you, Jeremy. Delightful to hear what you had to say. I'm looking forward to the Q&A that follows. We got a couple of questions that have come in. And Diana, do you want to filter through the questions? You and I can tag team a bit?
Sure thing. Well, the first question I've seen come in was about your presentation. So Jeremy, if you wouldn't mind sending that to me, and I can send that to the audience.
Yeah, absolutely.
Tomorrow morning.
Yep.
And on to a more direct question about your talk. Could Jeremy talk a bit more about the role of a data scientist and what training and skills are most important for data scientists?
Yeah, that's a great question. It's a great topic. Sure. So on the programming side, SQL, SQL, to me, that's a fundamental programming tool. Understanding how to join tables together, grouping, window functions. Once you know that, you've got to get into either the Python or the R. Both Python and R, they deal with data frames, which are just tables, and you can join them just like you would in SQL. The fundamentals are in SQL, but then you get this statistical modeling, the data analysis, the data visualization. So definitely SQL, and then pick a Python or an R. I probably skew Python over the R. We use both at Retina interchangeably, but prior to Retina, it was mainly Python. So that's on the programming side of things. I would I would read a little bit more on the statistics and probability than I did in my schooling. If I knew I was going to be in data science, I probably would have done more of that in my schooling. However, I had extensive linear algebra. Like my PhD was in functional analysis, which is on the cusp of like linear algebra and real analysis and linear algebra and high dimensional space. And so that has actually saved me in this field, because everything comes down to matrices and matrix factorization and things like that. So SQL, Python, or R, some linear algebra, stats, probability, and actually get your hands dirty with the data set. Like go download a publicly available data set and play with it. I would say Kaggle you can go to. I would not benchmark yourself on doing the competitions. You know, I would not, you know, people put that on their resume, like, oh, I scored in the top 1% in Kaggle. I don't look at that really. The Kaggle winners tend to know how to just parameter sweep and efficient ways, but you can go get a data set from there, or there's tons of publicly available data sets. You have to just start playing with it. And then, you know, do an analysis, a data analysis, and then try to make a presentation out of it. Very hard to do. Very hard to make a presentation out of a technical topic. It's so I would do that as like a, you know, at home exercise. You know, get a data set, work it through, and put a slide deck together on what you did.
Thanks for that, Jeremy. If I can tag on to that just one moment before we go on to the next question. How important is, in your perspective, domain knowledge of the particular industry or space that the data is being analyzed for? So
yeah,
you were obviously a math student. Did you have to learn knowledge of business?
Yeah, the higher you go up in seniority, the more it's going to matter. You know, if you're a junior person, like, you know, there's no expectation that you know anything about the business. If it's like your first job out of school, or if you know, or your second job even. And, you know, it's stuff that you can learn, the domain. I had no insurance background when I started at FICO, and I, you know, spent 5 years building insurance models. I had no experience in credit card and bank transactions when I went to Acorns. I built that whole organization, but, you know, I did help build their fraud detection system, which I had 5 years experience prior. You know, and then, you know, lifetime value stuff, I didn't have much experience coming to Retina. I didn't have much lifetime value experience at all, but I have built data organizations from virtually nothing for the last 5 years, and know how to do that. And, you know, I'd say if you have the domain knowledge, it's a bonus, a definite bonus, but it's not a blocker. It's not a blocker.
All right.
Got it. Thank you. Go ahead, Diana.
Yes. Next question. These are interesting uses of AI in the world of B2C marketing. Have you any insights into the use of AI in the world of B2B sales?
B2B sales. How about I just talk about in B2B in general? So FICO, it was all B2B. So we were selling our fraud detection software to other insurance companies. So I was building models for Kaiser Permanente, Cigna, Anthem. You know, I was telling Paul and Diana earlier, I went to Brazil to build a model for a Brazilian insurance company. So all my experience at FICO was in B2B. Acorns is all B2C, because Acorns is all individual consumers. And then, you know, at Retina, we're B2B. So we sell our lifetime value solutions to other businesses that want to know the lifetime value of their customers. Different flavors of work. At Acorns, you know, B2C, it's just very different. Like you have a lot of people spending $1 to $3 to $5 a month, versus B2B, you have these huge powerhouse companies spending millions of dollars on what you're selling them. And they both come with their own kind of pressures. They both come with their own kind of data problems. But there is one very common thread as a data science person, And the most common thread is knowing your customer. So you have to know who your customer, it could be an internal person, it could be another business, it could be the end user of your app. You have to know who your customer is either way, B2B, B2C, it doesn't matter.
Great insight there, thank you. There was a request for you to talk about your approach to predict lifetime value of a customer.
Yeah, I mean, I'll talk, that's very open-ended. I'll give a very short answer, because that's the crux of everything we do at Retina. Recency, frequency, monetary, looking at purchasing patterns, retention curves, understanding when people drop off and purchasing. There's a really famous class of models called Buy Till You Die, so you can check that out. And then there's really novel ways that you can actually predict lifetime value early on in the customer's journey without any transactions. So that's our proprietary software, but yeah, there's a lot that you can do there. You can look at retention curves of subscriptions, look at average revenue per month, model out retention. There's a lot of ways to go there.
And Jeremy, have you had an opportunity, or have you had a customer who's asked for a look not at revenue, but at margin? So some customers are costly.
Yep, absolutely. We do both revenue and gross margin analysis at Retina. Absolutely, it's very important.
Great.
Lifetime value is very important.
Okay, thank you.
Here's a question from a member of our math faculty.
Okay.
I like this one. What mathematics do you wish your non-data science colleagues were familiar with?
Oh my God. Like statistics 1, like average, median. What's the difference between an average and a median, and what's a percentile? Explaining like percentiles and deciles, and why averages versus medians, like just basic stats. I can't expect them to have linear algebra. I can't expect them to have more than that, but basic understanding of stats 101 kind of thing, that would be greatly helpful.
That's a really great skill set for any data science, is being able to translate those statistical words and concepts into everyday language for people.
Yeah, it's hard. Yes.
Combine a couple of questions here. There was a question about what the programming languages are that are most beginner friendly, and a question about those data science boot camps and whether in your opinion, those are worthwhile.
Yeah, I mean, I've not taken one. I've known people that have taken them. I think that, it'll probably give you a good intro to the space. I don't expect to go deep in it. I would, say, you're not gonna, if you're not a technical person, if you've done no math, no computer science, no data analysis at all, you're not gonna go from like nothing, take a boot camp, hardcore data scientist. I don't think like one boot camp is gonna change your whole life. It might, but you might have to put more work into it. I would definitely recommend it if you're interested. Like, by all means, go for it, do it. It'll give you a flavor of, a little bit of a lot of things, and see if you can like it. Easiest programming language, SQL is the easiest by far. But I actually would not choose what you study based on that. I would choose what's most useful and learn it. I would not go for easy, go for useful. Even if it takes longer,
Solid advice. Okay, and we have another question here from Edgar Cruz. As the only data person at a farming/warehouse business, what advice do you have to introduce new data solutions and technologies to a workforce that already struggles to adopt newer technologies?
Oh, Edgar. Okay. This is why I like being in startups. Is you're nimble, you get the latest and greatest tech, and you can try stuff. If you're stuck at a company that's set in its ways and you want to introduce a new technology, you have to find one person that's in management that can champion this for you and be a supporter. You have to get that. And then you have to actually, like, on your own time, go like build a prototype or build something and show its and demonstrate its value. You know, I think that's the only way it's going to go. But you have to get somebody else as like an executive sponsor that's going to help you push this through. Hard to do. It's hard to do. You have to show the value, though. Yeah.
It's another important skill
good
for the
stuff.
data scientist.
Yeah,
Knowing how to get stakeholders on board with the initiatives that you need.
Yes, it's a skill. You have to find the right stakeholders. Yes, that's part of it. Is finding the right people at the company. You know, pitching some problems that they might want solved. Yeah. Yeah, I mean, a lot of what I did in my last few months at Acorns was not data science. It was, you know, presenting, it was getting buy-in, it was convincing, you know, all that. It's not the technical. I had teams of, you know, an 8-person analytics team, a 5-person data science team. They were doing all the technical stuff, and, you know, I was doing the selling, internally selling.
Let's go ahead and take one last question, Diana, and then we'll wrap for the evening.
Yeah, sounds good. Let's see here. Perfect, because we have time for one more question, and we have one more question. Someone who currently works with data scientists and is not one, do you think it is worthwhile to learn data science on my own versus pursuing an advanced degree?
I would follow that up with, do you want to be a data scientist? I think if you're just working with, I mean, I would not go get a degree just to go converse with somebody else. That's a lot of work. And I think you can, you know, get by, you can do one of those boot camps to learn the lingo and stuff like that. But I would not go get like a master's or a PhD just to be able to have a conversation with somebody else. If you're going to do the advanced education, you got to really love it. You know, you got to really love to study that stuff and you know, put that in your career roadmap. Okay, I'm reading this. SQL developer, you interact. Okay, yeah. I mean, okay. I mean, if it depends what your goals. What your goals are. It says you love what you do. So if you want to continue being a SQL developer, like, I wouldn't go spend a lot of money getting a data science degree. But if you just want to be able to stay a SQL developer, just talk to them and do the lingo, like, yeah, do a boot camp or take a, you know, online course, or, you know, watch some YouTube videos or something like that.
And that is such a marvelous transition. Thank you, Jeremy. Number one, thank you for your presentation, for sharing that with this group. Thank you to all of you for being here. One of the things we do with this is we try to reach out to the community and offer some professional development opportunities that come in all sorts of forms. So I appreciate Jeremy's offering this tonight. Tommy's question and the answers to it are delightful, in that I'm in the business of providing higher education. So to the extent that that you can do what you want to do with YouTube videos and boot camps and whatever else you need, because you've already got a bunch of background and you've got an employer who will sponsor that, great. To the extent that you really need to get a whole package of stronger knowledge and skill sets behind you, maybe a higher education opportunity in one form or another is the right thing. I'll be happy to talk to any of y'all about that. I don't get paid by the student, so I'm here to figure out what's best for you. And if that means doing some YouTube videos, it's all good. So I look forward to conversations as you all see fit. Jeremy, thanks again. And Diana, do we have any closing words for the group?
Well, I would be remiss if I didn't mention that we have an excellent certificate program in data analytics where you can learn about R, Python, SQL, and more. You can learn more about those at CalLutheran.edu.MSIT. Apart from that, I just want to say thank you so much to Jeremy for joining, for all of your insight this evening, and to everyone else who made the time to come be here with us this evening.
Indeed. And thank you, Diana, for all your good work. As usual, nothing happens without the people who actually do things. That was Diana in this case. Jeremy, thanks again. We'll be in touch. And y'all take care and have a good and safe Thanksgiving.
Yes, happy Thanksgiving to everybody.